Hello Legacy Sabers, Marsh here. So today we're going to look at functions, basically what does it mean to be a function, and also function notation. In Algebra 2, guys, remember we focus on basically more complex functions than Algebra 1. So we're going to look at logarithmic functions, we're going to look at trigonometric functions. Here's a graph of those two. So we're going to look at more complex functions. But basically we need to know first, what does it mean to be a function? So your learning targets, remember guys, these do go up at the top of your page underneath what the title of the video is. I can state the domain and range of a relation. I can determine if a relation is a function. I can read functions written in function notation. I can evaluate functions accurately, and I can determine if a relation or a graph represents a function. So you can view these as function machines. So sometimes you have these input values, 1, 2, 3, or 4, and you have a rule. Basically this rule could be an equation or an expression of some form. Put them in. Let's say our rule is 2x plus 1. I will get output values based on that. So if I input 1 into our rule, I'd get 2 times 1 plus 1, we would get 3. So basically that's all a function is. This is also a relation. So a relation is a set of ordered pairs with a domain, which is your x values, and a range, which is your y values. Functions, however, are a special kind of relation. This is where each value of the domain is paired with exactly one range value. Now, sometimes this gets confusing for students, so let's put it into a real-world context. So right here I have a pop machine, or an Aquafina water machine to be general. Now, two buttons can lead to the same output. Notice guys, I have two red Gatorade buttons available for me to press, so both of them will pop out a red Gatorade. Now, the input values are the buttons I'm going to press. The output is the beverage that's going to come out. Now, can one button lead to two different outputs? So let's say I press the blue Gatorade button right there. I get a blue Gatorade. You come up, press the same exact button, and you're going to get a green tea. Is that correct? No, that's broken, right? That's a broken pop machine, right? If I push the blue button and you press the blue button, we should both get the same beverage, the same output. That means that this is a function, because if I press a button, I will get the same output each time. So, other real-life examples of functions. State and capitals. Now, each state only has one capital. There is not multiple state. There is not a single state that has multiple capitals. However, a non-function would be state and senator. In North Dakota, we have two senators. We have Hoven and Heitkamp. That is not a function, because you cannot tell you for exact which senator you are talking about. It'd be the same thing as me pressing North Dakota on a button for the button, and no matter, I'm going to either get Hoven or Heitkamp. I'm only supposed to get one. So, some examples in the math world. Let's first state the domain and range, and then determine if it's a function. So this first example, I have a table. So my domain is my x values, remember, 0, 1, 2, 3. My range will be the y values. Notice, guys, how I put them in order: -7, -4, -1, and 2. That makes it a little easier for you to look at the numbers. Now, does each x value have only one y value related to it? So 0 only goes to 2. Notice there's no more zeros here. 1 only goes to -1, 2 only goes to -4, and 3 only goes to -7. Yes, this is a function. If I press the 1 button, I'm only going to get -1 back. Let's look at a mapping diagram. These look a little different. So, first of all, our domain is going to be 1, 2, 3, 4. Our range will be B, C, D. Now, let's look. If I press the 1 button, I'm going to get D. 2, I'm going to get B. 3 I'm going to get C, and 4 I'm going to get C. Now, it does not matter if different x's go to the same y. I just can't have an x go to two different y's. So yes, this is in fact a function. No issues here. Each button is only going to give me one y value. Let's look at a different mapping diagram. So I have domain, -8, -5, 7. Notice it's the first one, first circle. Range, -6, 1, 2, 3. Now, is this a function or not? So notice, guys, how this -8 has going to -6 and to 1. That is not a function because I don't know what number I'm going to get from -8. I could get a -6 or I can get a 1. That's not right. That's the broken pot machine. Can't have that happen. Now, let's look at a list of numbers. Some students, they struggle a little bit more when it's a list. So, my range is we're just going to actually put those inside of a mapping diagram. Make it a little simpler, makes it a little easier for us to visualize, especially to see if it's a function or not. So, let's draw in our arrows. -2 is going to go to 0.5. How do I know that? Well, that is the point, the ordered pair that related it, right? 0 to 2.5, 4 to 6.5, and 5 to 2.5. Now, my domain, left-hand bubble, -2, 0, 4, and 5. My range, 0.5, 2.5, and 6.5. Now, does each x only go to one y? Yes, it does. It is, in fact, a function. Now, function rules are usually written in function notation. So, you normally, in Algebra 1, saw this as y equals 3x plus 4. Now, function notation is when we take the y and replace it with the name. So, this function is named function f. So, that way, if I'm talking about multiple functions, I have an idea of what I'm talking about. Because if I would have 5 functions and I'm trying to plug in a value for x, I'm not going to know what to plug into. The naming the function allows us to reference them easier when there's multiple ones being talked about. So this f right here allows me to say that it's function f. X is the input value, so that is what's present in the equation. X, or 3x plus 4, that is the rule for the function, so basically the expression or the equation if you want to consider it that. And entirely there, how do you read that? A lot of students don't know how. The value of f at x, usually you will hear me call f of x. Usually that's what you will hear. Or the value of f at x. So, let's use with function notation. First, I got f of x equals -3x plus 7. I need to evaluate x equals -2. So, what I'm going to do, for each x, I'm going to plug in a -2. So, f of -2 equals -3 times -2 plus 7. Now, f of -2, all that is saying the value of f at -2. I don't need to do anything on that side. That is just a label if you want to consider it that. Let's figure out this side. -3 times -2 is 6 plus 7. That is 13. So f of -2 is 13. Now, let's try it the other way. Find g of -1. Where's my x value? What do I plug in? I plug in -1. That is my x value. So, I'm going to write g of -1. Remember, guys, that is the value of g at the point -1, or the x value, -1. Now, for each x, I'm going to put -1 in its place. Oops, I messed up. Need to have a minus there. Bad hand. -10. Alright, so let's evaluate here. I got -1 squared. That is a 1, right? Because -1 times -1 is +1. Careful, guys, if you do that on your calculator, which I hope you don't have to, but if you do, please be careful. Make sure you put that -1 in some parentheses. Otherwise, you will get -1 out of that deal. 2 times -1 is -2 minus 10. 1 minus 2, -1 minus 10. And it looks like g of -1 is -11 for our final answer. Now, graphs of functions. So let's consider this. We're going to gather some information about people and their heights. And we're going to make some graphs. So I make 2 graphs from this. I have the name to their height, and then I also have the height to their name. So notice, guys, how on the left I have a function. Each x value has only one y value. Notice, guys, I'm only hitting it once. Look here, though. Each x value, 5, look how there's 2 y values. That is not a function. X has 2 different y values. That's the broken pop machine. So, how can you tell if a graph is, in fact, a function? The vertical line test. The vertical line test allows us to determine if a relation is a function if a vertical line drawn through its graph only passes a single point. Not 2, not 3, 1 single point. Basically, what you can do is you'll take your pencil and we will move it from left to right if it crosses more than 1 point at any point throughout your travel. It is not a function. Let's test it. Would this particular graph be a function? Here's my pencil. It's going to move. No problems there. But there are some problems there, right? I'm hitting twice. Not a function. Let's try another one. Is this guy going to be a function? Let's draw my pencil across. I hit once there. And I only hit once there. Is this graph a function? Indeed, I only hit once on the graph. This is a linear function because it looks like a line. Remember, you guys remember linear functions a little bit? Let's try this one. I have a circle here, or actually it's an ellipse, if you want to consider it that. Let's use my pencil here. So I have one dot there, only hit it once. Let's move a little bit over. Hit twice there. Is this a function? No, I hit more than once. Doesn't matter that I just hit once here. I hit twice right here, or anywhere in general. You need to be very, very careful. Make sure you check all pieces of the graph as you look through it. And that is the end of this video. See you later, Sabers.